So now we are going to go ahead and kind of implement that interaction in terms of the driver passing some data back to the user. So let's imagine what that means. So we were talking about like reading the proc entry, and then the proc entry was slash proc slash pajama driver. And our idea here was we are going to perform a read on this file, this proc entry, and as a result it will trigger the pajama read function that is implemented as part of the LDD driver, and that too as part of the driver proc operations here, right? And this is the mapping that we have, and so this function is what the kernel will call, but as a result, or rather this variable, this function pointer is what kernel will call, and it is mapped to this function right here. And in like previous chapter, what we saw was every time we perform this operation, we do see this print, right? And so now what we are going to do is, what we are wanting to do is, we are wanting that this function pass some message, let's say something like so, back to the user, and we will want to have something printed on the terminal as a result. That is our intention. And recall that whatever gets printed here is part of the user space, and the the driver is executing in kind of like the kernel space, right? And so we are now wanting to transfer data back and forth. Well, in this example, we're wanting the kernel to send back something to the user space, the driver to send back something to the user space. That is our intention. And so with that, the question is, how can a driver function like this, pass some data back to the user space? And the answer to that is that when this function is executing, when the kernel kind of executes this function, the input parameters here are populated by the kernel, right? Some of them are input, some of them are output, so on and so forth. But this one right here is a pointer that the kernel passes us for a buffer that's kind of in can be read by the user space, so to speak, right? So let's say this is that buffer. So what the kernel will do is pass it as pass it as sorry, my bad, it will pass it uh, let me just erase all of this. Yeah, it will pass it as the user space buffer variable, right? So this variable here will be pointing to the buffer that the user space can read, right? This is the user space, this is the kernel space, and this is representing that the user space can read that buffer. All right. So we are somewhere supposed to use, sorry, not that, but we are supposed to use, this pointer right here and do something with it. All right. So then turns out to implement this message now, we will need, a local string. And so let me have that string as, character array, and I call that array message. And in that, I want to kind of save, ack with an exclamation mark followed by a slash n, so that, a nice new line is also printed. Okay, so then I would also want the length of this. So I'm going to have, size t length. Size t essentially is same as kind of, unsigned int, so to speak. It's like the standard size that the CPU can handle. And so we are going to just have it as size t. Nothing wrong with making it unsigned int or just an int. You can try those examples. So I'm going to now say, hey, get the string length of the string contained in this buffer called message, right? And so now we have got the size, and the message is also ready. All we have to do is kind of write into this kind of the buffer or the character pointer, we are supposed to use that and write the characters. Okay, so what I'm going to do for that is I'm going to use an API called copy to user. And copy to user takes in destination, source, and the number of bytes to be copied, right? So what it will do is it will read all these characters, one byte at a time, and it will also copy it over into that user space buffer. So the destination then happens to be the user space buffer, the source happens to be message, and the number of bytes is essentially the length, right? So all right, so we have then we have our message here. That message we are copying over to the user space. And so things look all right now. So let me go to the terminal and do make. So as I do make, it complains or provides like a warning that I'm not using the return value of copy to user, the success failure, right? I'm not that return value is discarded. So now what I'll do is I'll also go ahead and kind of have int result, and then simply capture the return value in this variable result. Everything else, let's just keep it as is. Right, let me just go ahead and do make clean, then followed by that, let me just do make. And as I do make, this time around, things have cleanly compiled. Perfect. All right. So now first what I want to do is ensure that our module is not loaded already, like from the previous run. So that's not there. So that's a good thing. Let me see if our the kernel log buffer is cleared, and that is cleared as well. Now let's go ahead and do sudo insmod ldd.ko, right? And then when I do lsmod, and I'm going to kind of just grep for ldd, yes, that's available, right? So this was just to avoid all of the noise that this prints. And then you know just straight up we just search for ldd within this list, and we got this result right here. Okay, perfect. So ldd is loaded. That means our proc entry should also be available, right? Yes, pajama driver is available. Now what we want to do is first check in d message. Notice that there are only two prints which relate to the initialization of the module, right? So that is perfectly fine as we expected. And now what we'll do is we'll do cat slash proc slash pajama driver. Right? So our expectation or hope now is, and let me call that out explicitly here. So our hope is we are in the user space, and kernel space is what we are kind of going to invoke based on this read. But we are hoping that the kernel, or rather our driver, will pass back uh, you know this message to cat, and cat should print that, right? And one more thing that I should highlight, and let me just quickly do so here. This is just like a pure FYI. So the ACK here is an array of characters, right? And there are 6 of those, and the reason why it is 6 is what I want to explain. So we have this and then this, right? So this is not shown here, but a string is terminated by a /0, a null character. And all of this you see here. So the length of the string is actually 6. That is important, right? 1, 2, 3, 4, 5, 6. And as you see here, 1, 2, 3, 4, and 5, because the 6th character is hidden. We don't see it, but see, the way it treats strings are terminated. These are character arrays or character sequences terminated by a /0, a null character. Okay, so then what we are going to expect is this, right? This message right here should be printed by cat. So let's go ahead and execute this then. And nothing happens, right? We expected that ag be printed, but ACK is not printed. And so what is going on? So we do sudo d-message, and we notice that this print right here, the pajama read, well, that is coming from here, which then means that all of this actually executed, right? And if all of this executed, now why is, cat not printing anything? Well, the answer to that is we are supposed to return back the number of bytes that are returned to the user space, and the number of bytes we are writing is len. Right? We're writing these many bytes. Now, the other thing is cat will, once it knows how many bytes have been returned, or in the user space, how many bytes are copied over, so to speak, it'll then go ahead and read through that user space buffer and print it onto the terminal screen. So let's then, first off get uh, our module out, right? So I'll just do ls mod grep ldd not found, great. And then I'll also clear the kernel buffer. So kernel buffer is also clean now. Let's go ahead and do that again. Yes. And then I'll do make clean, right? So now let me compile our code with this one change right here. Right, so let me go ahead and do make. We'll repeat, sudo insmod ldd.ko, and then I'll repeat this module is loaded. Now let's do cat proc pajama driver, and something happened, right? Something bad is happening. It's never okay. All of a sudden, it's printing so much, right? And let me kind of kill this by Control C, doing a Control C. So ACK is essentially printing just too much to the point that it has frozen my virtual machine, right? So what is going on? And well, looks like okay, I'm in a very bad situation right now. So okay, great. My system seems to have recovered. So something happened here. We did see the message getting printed. We did see this getting printed, but it was continuously getting printed, and we didn't want that. Now the problem is cat is printing the same information again and again too many times. And why is that happening? Right. So let's just go ahead and do sudo d-message, minus, well, maybe not minus c, but d-message. And we see that the pajama read is getting called too many times, right? It's just going on and on and on and on. So the reason to why this is happening has to do with the fact that we are returning length. So the way cat works, well, the way cat works is that it is going to continue to read a file until it hits something called end of file, right? And it knows it has hit end of file when the number of bytes read or written into that buffer is returned as 0. And this is also why when we did not have the length here but had a 0 here, a cat would not print anything, because it was like, hey, 0 bytes are returned into that buffer, there's nothing for me to read. So what we would now like to do is convey to cat that it has read all of the information that we wanted to pass. And the way we go about doing it is we say, hey, you know what, this offset right here, this is the offset from which the subsequent reads happen. So first time when cat reads, we return it 6 bytes. So next time when cat reads, okay, let me just explain this little slowly. And we are trying to explore the use of this offset keyword. This happens to be an um, input output type of variable, because we can consume that value. We can also kind of, write back that value. So from that standpoint, this variable can be used as an input and output. All right. So think of it this way, that we had, too long a message here. Maybe we had something that was 1024 bytes, for example. And we chose to copy maybe, I don't know, maybe let's say 1 byte at a time, right? So now the question is, every time we just copy, so we are providing 1 byte here, and we are providing here msg in brackets, we are supposed to then kind of read an offset, because first time we'll copy this value, second time we are supposed to copy this value, so on and so forth, 1024 times, right? Each time we are copying 1 byte. So now the thing is, on a subsequent read, we'll need to read this again. We'll need to call this function in that case 1024 times to first off read all of that information. But the problem is, every time we call, we would also need to keep track of what index we are supposed to read from, right? And that is where this offset comes in. So if we update the offset on every call, right, in our case by 1, let's say, then what will happen is, on subsequent call, we can use msg, some syntax like this, to be able to kind of progress forward. I hope this is making sense. The idea is that the offset can be used to keep track of where to read information from on subsequent calls. All right, and this will make more sense when I talk about why cat was printing the ACK message again and again. So here's what was happening. The value of this offset by default is 0, right? If you don't modify it, the kernel just sets it to 0 and lets it be. The first call that the kernel initiates to this, the value of this, right, or the content of at the location of this. Okay, my ability to spell is just horrible, and just stay with me for a minute. Things will become a lot clearer. So offset, when we dereference offset, the kernel has set the value of this to 0 for the first call. And the reason to that is, the kernel knows that you will read from your local buffer wherever this message is. So this is our local buffer. So you will start to read from the 0th location, so on and so forth. Now, first time when this function is executed, we have read until the 5th byte, right? And that's how we have read a length of 6. The question then is, because cat got an answer 6, cat kind of printed the ACK message on the screen, but then because cat did not see end of file character, or it did not see that there are no more bytes to be read, it gave a call again. It issued a read again, and at that point, because the offset was 0, we started to read from the 0th offset again. What should have happened is, we should have tried to read from here, or we should have said, hey, we already wrote whatever we had to the user space buffer, and there is nothing else to be written, and so we should have returned the value 0. Once we do that, cat kind of gets to know that, hey, I read all the 6 bytes that were there, and there is nothing else to be read, so I can finally print this message and just exit, right? So all of this will make sense once I type in the code, and the code is this. So we were supposed to first off update offset by essentially the length. So, you know, so it's like, next time around when the same utility is calling, wanting to read the buffer, continue to read the buffer, we are supposed to read from, or rather skip over what we read in the first time, and then start reading from the updated offset, right? And there has to be like a star here. All right. And now here's the thing. We would need to check that if this offset is beyond the length, then we want to return 0, because there is nothing to be, read essentially. Right? And let me actually print this right here. Oh, actually not here. Let me go ahead and print it right here. Yeah, that way we know. Right. And at this point, then we are returning length. At this point, when the offset crosses the limit of the length, we say, hey, there's nothing else to be read here. Let's just go ahead and return a 0. Right. And now the interesting thing is, um, we can do this check on the top. Right. So let's just do our check here. And then let's say, hey, if offset is greater than or equal to length, because if we have, okay, this might become confusing, but stay with me. So we had six bytes to be read. So what will happen is the first time this value, right, is set as 0. So we come down here, we see that, okay, this is definitely not greater than length. So move on and actually do the copy, right? So the message, all these 6 bytes are copied over to the user buffer. Now, once that has happened, we say now update the offset to the new value of, offset plus equals len. The len happens to be 6, offset happens to be 0. So the new value of offset is 6 because offset equals offset plus len. So 0 plus 6, and that's 6. Now, next time around, cat is again trying to read this to get like more information. The value of offset this time around is 6, and now we are saying, hey, the value of offset is actually greater than or equal to, in this case it's equal to len. So we just return from here. We do not even attempt to copy anything, right? So that is why we have it up there, just to avoid kind of multiple calls from cat. All right, so let's go ahead, do make clean, do make, things compile fine. Now we are going to do sudo insmod ldd dot. Oh, actually, other thing, before all of that, let's ensure that our buffer is clean, right? So buffer is cleared now. We don't have the module inserted, it's already inserted. So let's take it out. Right, perfect. Let's clear the buffer again. Right, let's check. It's not there. Very nice. So let me just do make clean and make again, just so that we're dead sure that this is the code that is going to get executed. And now let's do sudo insmod ldd.q, right? And then sudo d message, yes, initialization worked, ls mod grep ldd, yes, our module is loaded. Now I'll do cat /proc /pyjama driver, right? And we only get ag this time, and it only is printed once, and no more repeat, prints, and things are all good, right? And I'll go ahead and do dmessage, so we see that the read happened twice. So the first time it happened, and this is important, right? So the first time the read happened, there were 6 bytes that were copied. The second time, when cat called it again in an attempt to read more data, we said, hey, you actually already read whatever there was to read, and we are passing 0 to you. So 0 was passed here, and that's where cat inferred that, okay, the buffer is completely read. I have read the file that I wanted to, and things are all good. And that's where it kind of just printed ag and exited, right? Okay, so now what do I want to do? I want to execute this once again, and you'll see that again 2 times cat has called the read, or rather it resulted in pajama read being called twice, right? Perfect. So with this, we have achieved our goal of reading from, or rather interacting with the kernel module and having the kernel module pass something back to the user, right? So what we'll do in the next video is write a Python script to attempt these reads, and then we'll kind of, go towards how you can do writes.